Hi, and welcome everyone. I'm Trisha G. I'm a developer advocate for JetBrains, so if you have IntelliJ questions, don't ask them to me. So this is my Java 8 in Anger talk. I have been told that I need to translate the term in anger. It doesn't mean I'm very, very mad at Java 8 and it's rubbish. It means I'm trying to use it in practice, I'm trying to use it in real life. That's kind of what it means apparently. In fact, someone who's from England said to me, what does Java 8 in anger mean? So maybe I just made it up, I'm not really sure. Anyway, so the whole point here is Java 8 has a lot of new features. We have a load of stuff around JavaFX, we have a lot of stuff around the tools, we have a lot of stuff around security and JavaDoc and Java Mission Control and all this cool stuff. And so it has one or two features. But of course, whenever anyone thinks about Java 8, really what they're thinking about is lambdas and to some extent streams and the collections API. So what we're going to do is, instead of doing kind of slideware examples of Java 8, lambdas and streams, we're going to build up live a real typing application which is going to take streaming data from Twitter and show it in some useful fashion. And so that you can see how to apply some of these new techniques, how to apply some of this syntax to the problems that you might face sort of every day in real applications. So who's using Java 8? A few of you, that's cool. Who's using Java 7? A lot of you, excellent. And who's still stuck on Java 6? Well, that's not so bad actually. Normally, so everyone now looks really sheepish. Oh, I'm really sorry, I'm still in Java 6. Normally at these conferences, I usually get a good 20% of the audience at least still on Java 6. So I'm quite surprised here in New York, we're only getting like 3 or 4 people on Java 6. So that's cool. So you can tell MongoDB that they can move to Java 7 now. There's a big fight. Are we being recorded? Right, so this real-world application, this is going to be a Twitter dashboard because live streaming data is all the rage these days. This is what we should be doing, apparently, even though, of course, most of us are just turning XML into Java and back again. So I'm not cynical at all. So we're going to build a JavaFX dashboard, and we are going to do some analysis over Twitter feeds, and we are going to show some of that data on a JavaFX dashboard. I'm not going to do like a big tutorial on JavaFX because most people these days are just genuinely not that interested in building UIs in Java. Most people are using JavaScript or HTML or whatever. But the fact is we do have this kind of cool new UI in Java, so we might as well use it. But on top of that, it allows me to build the UI using Java 8 features like lambdas and streams too. So that's kind of why I picked this particular technology, so that I can show Java stuff, not necessarily so I can show JavaFX stuff. So overall, this is going to be our overall architecture. The important thing is we have kind of Twitter coming in this way and our dashboard at the other end. And we have lots of very small services, independent services. One might call them, I don't know, micro-sized maybe. But this is not a microservices talk because these are not reliable services, they're not highly available services, as you'll probably see very shortly. But this is a talk about how you can kind of perhaps split your code up into independent services, and you can kind of see how to architect stuff in that fashion, rather than having to think about, I'm going to build a big WAR file and deploy it inside an application server somewhere. We'll go through all of those individual services as we build up the application, so I put it there to scare you up front. If you feel like it, you can download the code and have a look at it or browse it on GitHub. So feel free to take a quick snapshot of that. And there's more than one branch in there, but there's 2 main branches that you might be interested in. The master branch is the whole application, sort of finished app, so that's a good place to go and have a poke around and see what I did. There's a skeleton branch that you can use to kind of, which is where I'm going to start from. So you could start from the skeleton and build it up as you go as well if you wanted to sort of play along. So let's get started. I had several widgets on my UI. I'm going to build a leaderboard of the top tweeters on Twitter. So not necessarily the top tweeters on Twitter overall. Let's assume that maybe you're doing some analysis over a hashtag for a conference like this. And maybe you might want to find out who are the top 10 people who are most active on this hashtag. So we're going to have like tabular data, we're going to have their Twitter handle, and the number of times we've seen them tweet. Okay, so it's fairly straightforward, it's quite simple. The first thing I'm going to do is I'm going to build up this individual service. So instead of having to build the whole application end to end just so that I can have a look at one particular widget, I'm going to build a stub service to begin with. And this stub service is going to sit there and emit strings over WebSockets which look like Twitter handles. And this is just going to allow me to kind of build up my UI without worrying about wiring in the whole architecture to begin with. Oops. So let's do that. And let's put this down here so we can see things. Okay, so what we should be able to see, let's try and make it a little noisy. Can everyone see that okay at the back? Okay, so what I've got is I have a simple array of a bunch of 3-character strings which are going to represent my Twitter handles. There happen to be 27 of them. And I'm going to build up, I have a class, I created this class called stub service. It kind of spins up a WebSocket service. And I tell it which path to run at. So I'm going to run it at users because it's my user service. I tell it which port to run at. And this is where we see our first example of a lambda.
Excuse me, is there a dimmer in this room?
Is there a what? A dimmer?
Dimmer.
I don't know.
It's hard to see.
Can we dim the lights? Can we get intimate? Don't pull the whole power out. Oh good, the only lights that we want to get rid of are the ones we can't get rid of.
No, that was better.
That was better?
Yeah. That was good. It's good, yeah, it's good. Yeah.
Oh, that's cool. And the good news for you guys is that if you start to fall asleep, I can't tell now. I can't see you. Okay, so yeah, so I have this array of Twitter handles. And what I want to do is, I have my first example of a lambda. We'll see more lambdas obviously as we go through this example. But the point here is that my stub service encapsulates everything I need from a sort of infrastructural point of view. And all I need to do to get this service up and running is pass in a tiny piece of functionality, which is the business logic for this stub service. And that business logic is randomly pick one of these example handles and emit that, publish that, that Twitter handle. So this is not the most exciting example, so I'm just mostly going to skim over this. So let's get this up and running. Hope that nothing goes wrong at this stage, because otherwise we're off to a very bad start. Great, that's a great start. Okay, so we have our stub service up and running. So the next thing we want to do is we want to create this sort of model view controller side of stuff, which is going to connect to that service, do something useful with the data, and display it on that table of leaderboard of Twitter users. So here we're going to take our first look at JavaFX. If you have done any Java UI programming, because maybe you've been doing Java for as long as I have, like in terms of applets or Swing or stuff, it's not super unfamiliar to us. We have kind of like this stage, we extend this application. But like I said, I'm not going to go into that in much detail because it's not very exciting. What I do want to do is I need to connect. I've separated out the concepts of model, view, and controller. And what I want to do is I have these data objects at the top, which are my model, and I want to connect those to the stub service, so they start listening to those events and reacting to them. So I need a client endpoint. Oh, that's not that one. And I need to tell it where to connect to. This is a class that I've created. I am using some IntelliJ keyboard shortcuts. Well, sorry, that's a live template massive cheat because I don't want to mistype the URI. So IntelliJ hasn't magically picked up the URI of that service. That would be really smart. That's just a cheat that I put in there. And so what I need to do is I'm going to add a listener to this endpoint. This listener is going to be my leaderboard data object. So this needs to implement message listener. So we need to implement an onMessage method. Okay, so what this class needs to do is the message that we're going to get. Let's rename this so it's kind of more useful. This is going to be a Twitter handle. It's going to be a string, which is a Twitter handle. And what I want to do is I want to keep a record of every Twitter handle I've ever seen and increment the number of times I've seen it, so that then at some point I can kind of do some ordering and display that in some leaderboard. Now this is easier than it ever used to be because there are some new methods on HashMap. I'm going to store them all on a HashMap. I'm going to pretend I've got infinite memory and this HashMap can grow infinitely, so let's just gloss over that particular detail. But I'm going to put all the Twitter handles I've ever seen in this HashMap. And what I would normally do in the past is I would have said of that HashMap, I would ask it if the Twitter handle is in there, and then if it's not, if it returns me null, then I have to create a new Twitter user, I have to insert it into the HashMap. You don't need to do that with Java 8. You can call a method called compute if absent. So I'm going to pass in the Twitter handle, and then I pass in a piece of functionality to call if I'm having trauma because I keep switching between the Mac and the Windows machine and confusing the hell out of myself. So I'm going to pass in some functionality to run if this Twitter handle is not a key in the map right now. And I'm going to do this as an anonymous inner class to begin with because I'm still kind of getting to grips with the way that lambdas work. So this way I can kind of see what my parameter is and what my return type is, and then I can write my method the way I kind of expect it to, and then I'll get IntelliJ to do some magic. So what I want is, I happen to be quite lucky in that all I need to do to create a new Twitter user is hand in the Twitter handle, which is what this is. This will be the handle. Okay? So that's how to create a new Twitter user if it doesn't exist in the map. I get IntelliJ to shorten this to the shortest possible thing that will work, which happens to be a method reference. I could have, if I wanted to, I could shorten this to a lambda. So the lambda is pass in the handle and return me a Twitter user. Or I can just basically say, Java 8 will figure out, well look, if you're taking handle and then passing that straight onto some other method, what we can actually do is just tell me which method to use. So that will be the constructor of Twitter user. So I don't know what people are complaining about with all the Java boilerplate, because boilerplate is not a problem anymore. That's not true, by the way, this is a joke. So I've quite simply, I've got myself a Twitter user. Either this was an existing Twitter user from the map, or a brand new Twitter user that I've created and then added into the map. So of course what I want to do is I just need to increment the number of times I've seen this person. So let's increment the count. Okay, so the next thing I want to do is I now have my enormous hash map of all the Twitter users I've ever seen. I want to reorder this according to the count of the number of times I've seen them. And I want to limit it so that I just have the correct amount shown on the screen. So let's get the values, because it's just the Twitter user types that we want. Now we get to use the new strings. So I said I want to reorder them, so I use sorted. Now, in the olden days, like yesterday, we use comparators, right? And you have an O1 and an O2, and you have to minus O1 from O2, or was it O2 from O1, I can't quite remember. And that's how comparators work. And this is one of the places where we did use lambdas in the olden days, because we used anonymous inner classes for this quite a lot. Now we're not going to use that, because in Java 8, we have some nice new features. We can still use comparator. There's a method called comparing. So I can say comparator.comparing, and then I tell it which method to use to compare those two objects. So I want to use Twitter user get tweets. That's the value that I want to compare those two objects on. But it needs to be in descending order, because obviously I want the most popular one at the top. So then I just call reversed. And that's all I need to do. And of course I can make this even neater by doing my static imports for these things. So now I've sorted all my values in order. I'm going to limit them. And then I'm going to collect these into a list. That's one. So then let's store these in a list. This is the top tweeters. That's all going to go off the end of the screen. Now the last thing we need to do is to get JavaFX to display it on the UI. Like I said, I'm not going to go into the details of JavaFX specifically, but what we do need to do is we need to set this observable list to be this new set of values. That's how it's going to get displayed on the UI. So I'm going to say items.setAll top tweeters. There's one tiny problem with this though, which is that this is running on one thread, which is a client endpoint listening to the user service. So that's one thread. And this items object is being read and listened to by the UI thread, which is a different thread. So I can't really go around willy-nilly changing objects that the UI thread wants, because you get the equivalent of sort of concurrent modification exceptions. So instead, I want to tell the UI thread to run this bit of code when you get round to it. So I say run later, and then I turn this into a lambda. And then that will delegate that particular piece of code to the UI thread. What have I done?
What is that? What's platform?
This is a JavaFX thing. So this will just basically say to JavaFX, tell the UI thread to do this bit when it's ready, because it has its own life cycle. So we've wired up the data to listen to the user service. The next thing we need to do is, well, we need to connect to the user service. And then we need to create the view. We'll do that fairly quickly because I'm going to guess that the JavaFX stuff is not super exciting compared to the Java 8 stuff. So I'm going to configure my view in FXML. You can do it in Java in JavaFX. I've just decided to put it in FXML so that I get a clean separation between my view and any of my logic. This is kind of wired into a leaderboard controller. My leaderboard controller has a table view because I'm going to want to show this in some sort of tabular form. So then all I have to do is define a table view in here. I need to give it an ID. IntelliJ picks up that this is the ID of the table view in the controller. And because it's a table, I'm going to need some columns. I've got a shortcut for IntelliJ, which I created myself to create columns because there's a bit of boilerplate there. This is going to be the Twitter handle. I need to bind this to a property called Twitter handle. So I need 300. And do the same thing with the count. So this will be count. This is the tweets property. And this is 180. So that's the view, just define the view of this table. And then the final thing we need to do is we just need to glue together the controller and the data. So theoretically, when I run this, we should get a leaderboard of data with the fake Twitter handles from our stub service. The moment of truth. This usually goes wrong. Oh, nice. I put the height wrong, but you can see that it's reacting to the data that comes back from the user service, it's ordering them correctly, and it's incrementing individual values when it sees that value get updated. Okay? I'll just change the height of that so that it doesn't drive me crazy. We just have to set this here. And the last thing we can do is we can style this as well. We can style this using CSS. So this is a bit small for me, and I'm stood right here, so I'm going to make the font a little bit bigger. So we can choose to style this with CSS. I mean, I figure it took us like 15 years to figure out how to use CSS, so we might as well use it for JavaFX as well. So I'm just going to set the font size. These are JavaFX specific CSS properties, but again, like it's not rocket science, it's fairly straightforward.
I still haven't figured out CSS.
Oh yeah, me neither. So let's restart our dashboard. So here we've got the correct height and a slightly bigger font size. Okay? So, we've done our stub service, we have our leaderboard, model view, and controller. What I'd like to do now is I'd like to do some mood analysis over the tweets. We're not going to do the analysis just yet, we're going to create, obviously, well, okay, I'll come back to that in a minute. So for example, I want to look at, are tweets generally kind of sad? Are they sort of happy? Are they a bit happy and sad? I mean, it's very crude mood analysis, but let's say we only care about happy and sad. So I'm going to create a stub service for mood the same way I did for user, so I can kind of create this UI for that. So this will be, you'll see that this is pretty much the same thing. Instead of having Twitter handles, I have my moods are either happy or sad, or a comma-separated set of values of happy and sad. And then I randomly pick which one of those to emit. Okay, so it's the same thing as the user service, so let's just get that started. And let's move on to the bit where we're going to glue this, the mood service into the dashboard. So once again, we're going to need to connect to the endpoint. This time we're going to do something a little bit more complicated. If I can remember what I'm doing, I need a So let's connect this to our mood service. And before, all we did was we did a straight connection to the user service. The user service was emitting strings, which was our Twitter handle. So we didn't do anything clever with those strings. We just kind of kept treating them as strings. What we're going to do with the mood service is we are getting a comma-separated set of values. So we need to do some parsing on it to pull it into something more sensible than just a string CSV. So here we're going to work with lambdas again. I need a message handler. This message is going to be a CSV of happy or sad. So I need to turn this into a tweet mood. So I need, I've got a thing called a mood parser. I'm going to parse that. And once again, we get IntelliJ to turn this into something more Java 80, which once again is a method reference. So this is a mood endpoint. Oops. And we can add listeners to this too. So, our mood chart data is going to need to implement mood listener too. This is going to need to do a slightly different thing when it gets new moods. So these pie chart data types are JavaFX types. So I have 3 slices to my pie chart. I have a sad one, a happy one, and a confused one for tweets which are both happy and sad. So what I want to do is I want to look at the message. I want to look at the message. I want to figure out whether it's happy or sad and increment the correct portion. So if my message is happy, then obviously I want to increment the happy portion. And if I copy and paste, things always go wrong, but let's try copying and pasting. There's a couple of things that are less than optimal about this code. One is obviously, I said it myself, I copied and pasted stuff, which is never really a good sign. And 2 is the fact that if you are doing a set and a get in the same line, just because it's in the same line of code doesn't make it an atomic operation. So I happen to know that this is called by one single thread, so I can safely do that. But if you're doing a get in a set, normally you have to think, is this going to be thread safe, or do I need to do some sort of atomic increment instead? So let's refactor this out, because there's no point using IntelliJ if you don't actually refactor things with it. So let's turn this into a message, into a method, increment pi, and we are going to pull out the bits which are specific. Call this criteria. And then IntelliJ figures out, oh, actually, since you've done that, I can replace these 2 things because they're exactly the same thing. So I'll replace both of those. So that's one thing we can do to simplify our code. We can actually go one step further if we wanted to, and this is where we start to have to weigh up the trade-offs of what's more readable and what's not more readable with Java 8. But let's say, instead of passing in two things, a Boolean and an object to do something on, let's say maybe we actually wanted to pass in a piece of behavior. We want to design our own method which takes a lambda. So we could actually change this to pass in the behavior into this method, instead of just the object. So there's a nifty new shortcut, which is Control-Alt-Shift-P, which will allow me to, IntelliJ will select a functional interface that matches the signature for this piece of code. Now, because it has no parameters and returns no value, it's suggesting that I use Runnable as the interface. So it's called Runnable up. I'm going to call it Runnable because I'm a bad person. I don't name my variables properly. Turn this into a set of lambdas. So this is kind of how we can start thinking about maybe refactoring some of the behavior out so that the caller has some decision-making over what happens inside that code. Now in this case, I would argue that since it's actually the same thing happening in all three places, and it's quite big inside a lambda, we probably didn't gain that much by refactoring it into a lambda in this case. But you can take a look at this stuff and figure out whether you want to make these sorts of changes to your code or not. If this was more general rather than an increment, and you were just going to do something arbitrary on some UI method, this might be a bit more useful. So we've done our mood chart data. So let's do our UI for the mood chart. And the UI turns out to be quite simple. Obviously we want a pie chart, because that's what I said we were going to do. So we will create a pie chart. We give it an ID, and we give it a title. And then that's all I need to do to define a pie chart in JavaFX. Finally, let's connect to our endpoint and glue up the control of the data. So what have we got running? We have our mood test data running, our user test data running. So when we restart the dashboard, we should see our pie chart appear in the top left-hand corner. Okay. And you can see it's dynamically reacting to the new values that come in and animating itself. I didn't have to do anything to get animation, just JavaFX kind of comes built to do that kind of thing, and to rescale things and to resize things. So you can get things like these dynamic dashboards for very little effort from JavaFX. Now I don't like the colors in there because I think happy should be a much happier color than murky orange. So let's just quickly change that. So then I can change the color of the different pie slices. Okay? So, we have our user self-service with a leaderboard. We have a mood self-service with a pie chart of overall mood. The last thing I want to look at is not just overall aggregated mood. Are we generally happy? Are we generally sad? I want to look at happiness over time. Is it getting happier? Is it getting sadder? Are there blips? What do the patterns look like? So I want to trace this over time. So this is our last widget that we're going to show on the UI. We're going to show this as a moving bar chart. And we can, of course, reuse the same stub service. We don't have to have a different service. This is using the same data. It's just going to do different things with it. So here, because we're using the same data, we're using the same endpoint, I can just add a new listener to this mood endpoint, which is my happiness chart data. Happiness chart data already implements onMessage because onMessage was really boring and not very Java 80, so there wasn't a lot of point in demoing that. However, there is something interesting about the happiness chart. So it's going to have 10 bars in it from the now minute, which is 00 apparently because it's edge clock, from the now minute to 10 minutes time, so from 0 to 10 and on the bottom of the bar chart. But we need to set all of these to 0 because as new data comes in, we're going to increment them. If we don't set them all to 0 to begin with, we'll get a null pointer exception. So firstly, we need to find out what the now minute looks like. So here we have a quick peek at new date and time. One of the things I like about new date and time is the methods do what they say on the tin. If I want to know what the time is now, I call a method called now. It gives it to me. And what I really want from now is I want to know the minute, so I call getMinute. So there's no messing around with old style dates, which might be in longs, and you might have to do offsets and shifts, and I don't really know where I am. And you can just do this fairly straightforwardly with a kind of DSL style with new date and time. So I'm going to call this now minute. And what I might have done in the past is I might have done an iteration until now plus 10. I might have started at now. And what I want to do, I have a method called initialize bar to 0. So I think we've probably all written code a little bit like this. From some value to some other value, I want you to call this method all that many times because I'm going to initialize all 10 of those bars. There's another alternative in Java 8, which is just different, and you can make your own decisions as to which you prefer. As well as just getting streams of collections, we can actually create our own streams. So I'm going to create a range, from an int stream, which is a range, from now until now plus 10. And then what I want to do is, for every one of those, I need to call initialize bar to 0 for a value. And again, I can turn that into a method reference. So I've gone from 3 lines, granted there were 3 lines because there was curly braces in there, to 1 line of code. Now for me, I think this will depend very much on your team, what feels more readable, what feels right. And also a number of people told me that there might be performance implications to this. So for a loop like this, probably doesn't matter at all, there's like 10 things in there. But you have to consider that perhaps this works in a slightly different way, there might be performance implications of this. So you have to make your own decision as to whether this is better or worse, but you have different options for looping than you used to have before. So oops, I don't want to get rid of both of those. So we've done this. We need to glue in our controller and our dashboard and restart our dashboard. Oh, now, this is good in a way, because like, A, when things go wrong, people love that. B, you get to see what a stack trace looks like when it's inside a lambda. It's not super pretty. It's kind of, it's gone away now. It's not super easy to debug lambdas. It's possible, but it's not awesome. So what did I do? I have a null pointer exception. What have I done? I have a null pointer exception somewhere. Oh yeah, I didn't create the UI. That is not super useful. So I need to go in and I need to create my actual bar chart. So what was it called? In happiness controller we have a, yes, bar chart. So let's create a bar chart. We give it an ID. We give it a title. And we need to give it a x-axis. The x-axis is going to be time or minute. And we need to give it a y-axis, which is going to be count. So now we should be able to restart our dashboard. That's better. Okay, so this is, so it's, yeah, 5 minutes past 8. So the first bar is at 5, it's 5 minutes past 8, and 6, 7, 8, 9, 10. JavaFX is going to automatically rescale the axes according to the numbers that come in. You can make this prettier. I would get rid of the legend, I would get rid of the various ticks, and you can do things with the animation to stop things flashing so much. But you saw that with very little XML and a tiny bit of code, I kind of got this animated bar chart out of the box without having to do any more messing around with the way it looks. The only messing around with the way it looks I will do is I would like to turn the color into green because it's happy, not sad. So let's turn that into green. Let's first check, see if, I want to see it tick over to the next minute, but that does sometimes mean staring at it for 60 seconds. There we go, thank goodness for that. So you can see that as we get on to the next minute, then we increment the bar chart for the next minute. Okay, so now the bar is green. So we've created our overall kind of crude dashboard very, very quickly. We've wired it up to stub services in the back end so that we can prove that the UI side at least does what we want. And the UI does use Java 8 features such as lambdas and streams and some of the new date time in order to create the thing that we're actually seeing on the UI there. What we really want to do though is that's all well and good. We're publishing stub stuff. You can see the UI works. But the interesting piece here is when we start to connect it to real data and actually do some analysis on the real data. I'm not going to connect it to Twitter because I don't trust the conference Wi-Fi that much. So what I've done is I've downloaded some Twitter data into a flat file. So I've got like 60 minutes of Twitter data from a Saturday morning in a flat file, and I'm going to create a service which is going to read that file with the genuine tweets which are in there and emit those as if it was a real service, parsing data from Twitter and emitting those tweets. I feel like some people keep taking photos, and I feel like every time I flick the slide, it's just before you've taken the photo. I feel for you. The slides are online, so I can point you to them at the end, so you'll be able to see them. And so we're going to create this canned tweets service. Now, this is going to be a combination of Java 8 and Java 7 features. So, has anyone really used any of the new Java 7 features like try with resources? Okay, and new file I/O stuff. Oh, cool. Okay, a few of you. Okay. I mean, generally we're not doing file I/O all the time because we're probably doing something wrong if we are, but it is a lot simpler in Java 7. So, just to simplify really what this class is doing, I have this file, tweet data 60 minutes. I'm going to publish the data at the path of tweets at a URI of 8081. So I'm just going to start a little server running on WebSockets to emit this tweet data. What I really want to do, the interesting bit here is I can use a new method on files called files.lines, give it the file path, which will give me a stream of strings of all of the lines in the file, which seems to me to be a lot more sensible than previous ways of iterating over file, IO, byte, buffer, stream, something, something, something. What we can do as well is we surround this with a try with resources block, so we no longer have to catch everything and do finalies everywhere. And we can add a catch clause here. This is terrible, so to do real error handling. Just like real life, right? So I have a stream of lines. And what I want to do is I'm going to iterate over those lines. I happen to have in this file some of the lines are a string that just says the word OK, which I assume is where Twitter responded back to me and said, you're still connected, everything's fine. But I don't want to send that on, so I'm just going to filter that stuff out. So let's filter that out. We filter where we don't want, where S is equal to OK. And then for everything else, I want to call...
Is it null save?
Sorry?
Is it null save, S equals OK?
Yes, but only because I happen to know there are no null lines in that file. So yeah, probably first thing to do is filter out any nulls.
What it means is that as you stream over the lines that it will give you an empty string and not a null as part of the contract?
I don't know. I don't know the answer to that.
I don't think there's anything as a null line because it's reading it from a file, and if there was nothing on the line, it would stop reading.
Right, or return an empty string, or
yeah.
So I don't think there would be a null, but I wrote a test for this, so it never fell over with a null pointer exception. What could possibly go wrong? So then for each of these, I need to let's pass an S1. So what I'm doing is obviously filtering out those OK lines, and then for all of the remaining ones, I'm passing them on to this method onMessage for tweets endpoint. That's the server endpoint which will publish this message to anything which is listening. Let's check we've done everything we're supposed to do. I don't want Okay. Oh yes, there is one more thing. So, contrary to popular belief, reading files is actually remarkably fast. Obviously it's not as fast as reading stuff from memory, but it's too fast for my demo. So what I'm going to do is I'm actually, rather than starting to mess around with batching up messages or doing like refreshes in periods, I'm going to do a massive cheat here just for the demo. So I'm going to use peek, which is something which lets you see what the status of your stream is at that point in time, and I'm going to do a massive cheat and call my method called add artificial delay. At least I named it properly, right? So what I could have done is in my for each, I could have had a lambda which has my curly braces and is more than one line long, and it could have called artificial delay and called the on message method. But I quite like the fact that I've put this in peek, so when I want to get rid of this, I just delete that line and then we get rid of that. But I do need that. So let's run this. And it's not erroring yet. Good. So where we are, it's not connected to anything just yet. This is just a service running in the back end. What I want to do now is I want to create a real-ish kind of user service which is going to take this whole Twitter message, which is like a big lump of JSON, which has got everything to do with Twitter in it, and I want to extract out just the Twitter handle. So this is what my user service does. My real user service parses those strings, extracts out the Twitter handle, and then emits that. From the leaderboard MVC point of view, it sees exactly the same thing at exactly the same URI. Now, I've actually, again, managed to extract out a lot of the infrastructure into a class called service, which we're not going to look at because we actually don't need to. So let's create a new service. This is going to take the endpoint to connect to, which is my Twitter endpoint, my Twitter service endpoint. This service is going to start up at /users. It's going to be on port 8083. And then I'm going to pass in another message handler, which is going to have a Twitter user. So what does this do? This message handler is, like our other lambdas, this message handler is the business logic for this service. And the business logic for this service is to parse this message, which is the tweet message, and turn it into a Twitter user. So I have a tweet parser. I want to get the Twitter handle from this message, and I need to return a new Twitter user with that. Let's static import that. And then, of course, we can turn this into a lambda. So if you can see that, the whole business logic of this user service, granted it's a very tiny service which is just extracting strings from a Twitter string, but the whole business logic is in that one lambda. Create me a Twitter user by getting the Twitter handle from the Twitter message I just got. So I should be able to stop my fake Twitter service, start my real Twitter service, restart my dashboard. These are not super robust services, so I sometimes have to restart everything. And so now you can see that those are like real Twitter handles on the right-hand side because they're no longer my 3 characters. And you can see it's doing the same thing. It's reading them, it's updating the count, it's reordering them. Okay, and these are Twitter handles from real Twitter data. Okay? So finally, let's do the mood analysis bit. I'm sure you're going to be disappointed with this because everyone thinks this is going to be some super exciting mood analysis. It's not really, because this is a 50-minute demo, so there's never going to be time for that. But what I'm going to do is I'm obviously going to replace my mood stub service with a real mood service, and we're going to look at the guts of this mood service. Not surprisingly, it looks quite a lot the same as the user service. We need a new service. We are going to connect to the same Twitter service that the user service connects to. We're going to start it at moods on port 8082. And we need to pass it a message handler as well. And then this message handler, this takes the whole tweet and it needs to do some analysis to figure out what the mood is. So I have a mood analyzer, analyze mood with that message. What are we going to do here? We will turn that into a method reference. So here we're basically saying the whole business logic of this service lives in that method. So let's check this method. So my mood analysis is naive, crude, stupid, I'm not sure. Only on English language stuff. What I want to do is I get an array of strings, which is all of the words that were in the original Twitter message. Not the whole thing of Twitter with their handle and the location, just the 140 characters that they tweeted. And what I'm going to do is I'm going to look at every one of those words in the message and find out if it's in this map, and then figure out whether it's kind of happy or sad. So, not surprisingly, we're going to use streams to do this. So we can say stream of our array. We can say, the first thing I want to do is, you'll notice that these words in this map are all lowercase, so I need to turn all of my words in my message to lowercase. So here I'm going to do s dot to lowercase. That can be a method reference. We need to map this lowercase word to a value in the map. So here we're going to say word to mood dot get the mood that is the same as s. This also collapses down to a method reference. I don't know if you can see that at the back, so let me just move that up a bit. And then I need to filter out the nulls because it might not be in the map. It might return null. So back to the question about is it null safe? This one is not. So then my mood that I get back, if its mood is not equal to null. And then finally, I'm going to collect these into a set. I actually don't care whether there are 3 happies and 2 sads or 1 happy and 3 sads. I just care, is there some happy, is there some sad? So I just collect this into a set. So that's all I needed to do in order to do some really crude mood analysis over a sentence full of strings. I just do some MapReduce type operations on it using Java 8 strings. There's one final piece to do. I said that it was going to be a comma-separated set of values which I was going to emit from the service, from the mood service. Now, I am naively, my service is just using the toString method to figure out how to serialize this object into something stringy. I'm going to carry on using the toString method because it's easier. But let me show you what you can do. That's the second time I've done that. What I want to do is this set of moods, I can't just do a toString on the set of moods. I want to look through them, turn them into the enum string version, and then put a comma between them, CSV thing. But instead of using, previously with our collectors we used lists and we used sets, but there are also other collectors like joining. So I can join these values with a comma, which doesn't look like rocket science until you think of the number of times that you've written that for loop to parse each message, put a comma on the end, and then right at the end, take that last comma off the end, okay? You don't have to do that, just use joining, that will just work. So the last thing we need to do is we will stop our fake mood service, check our other service is still running, run our new mood service. Rerun the dashboard. Oh my goodness, it worked. I'm amazed. So we have our real username data obviously on the right hand side, and we can tell this is correct, this is real data from my test data set, because very weirdly on a Saturday morning everyone was tweeting largely happy stuff. I was amazed. And it turns out if I didn't do the translation to lowercase, I just did a case sensitive match on the moods, that actually people were more unhappy. So I don't really know why that was, but Try and pretend that things didn't just completely freeze, by the way. Nothing happened. But you saw it work for a bit, right? Oh, it's fine. I ran out of data. My data doesn't last very long. I'm stubborn, so I'm going to go and restart all the services. But no, I'm not. Yes, I am. That'll be fine. If it doesn't work straight away, then you saw it working, so... when I demoed it at QCon yesterday, it didn't work because I forgot about the nulls and I got a null pointer exception, which is really embarrassing in front of 102 people. But it was fine. Yeah. Anyway, so that works perfectly fine. And we've built up our whole application. So we've built up something which parses tweets and is a tweet service and turns stuff into something parsable by a mood service and a user service, a number of different widgets on the UI, and makes sense of it. So we have a number of services running in the back end now. I'm not going to do this because I don't trust the conference Wi-Fi, so I'm not going to connect it to Twitter. And there's no Java 8 stuff in that anyway. That's just mundane Twitter wiring stuff, which takes 3 times longer than any of the rest of the application put together. So, what have we learnt? Hopefully, we have learnt how to use streams to manipulate data. So we saw streams when we were doing our leaderboard. We were using streams in order to reorder our stuff, to limit things. We saw streams when we were doing our crude mood analysis to figure out, how a particular sentence is going to map to certain moods. We saw streams, we used the joining thing to create our little CSV using streams. And where lambdas might simplify your code. So by you passing in lambdas, by passing behavior to certain things, we can do things like create very general, like I've created a general service class, which has no specific individual service functionality in it, and I can just inject in the bit of business logic that I need for that specific service using lambdas or method references. Where else do we use lambdas? Mostly with the streams. We use lambdas a lot with streams too. And we also saw the basics of building a JavaFX UI, and that took a lot less time to learn than I expected. I'm not a UI person, and I learned it just for this demo. And we got that kind of nice, dynamic, updating, animated dashboard pretty much for free out of the box. And JavaFX comes with Java 8, so you've got it there. You can play with it if you want to. I have links to the code here. I have links to videos of me giving this presentation. I have a lot of links that point to more information about WebSockets. I said I was using WebSockets, but I didn't go into them in any detail whatsoever. So there's some WebSocket stuff there, there's some JavaFX stuff there, there's some links to some stuff on microservices, and there's the code and all sorts of stuff here. No, I can't. I've run out of things to say, people are still taking photos. Anyway, well that's fine actually, because the next slide is just questions anyway. So there's time for questions, right? Like 5 minutes or something? Yes. Right, any questions? Never have time for questions. Yes?
Can you show something with optional API? Because in Java 8 we introduced some optional API.
Right, so can I show the optional API? I actually wanted to put optional into this code because optional is awesome. So instead of having nulls and stuff, I can sort of basically say, if it's present, do this thing, and if it's not present, then don't do that thing. Instead of saying, if I'm null, then, I don't have a good example of it, and I could hunt around for a while, but optional is well worth looking into. If you're building APIs, I'd really consider returning optionals if there's any chance that you could be returning null at any point in time. Optional is really cool. But it's going to take a little bit of getting used to. Like I've seen people already starting to use, you can do optional.if present, do it in an if statement, and put your thing inside the if statement, and you're not really supposed to do that. You can pass that in as a lambda to the method inside. I can't remember what the method's called in optional, but they're worth taking a look at. Optional is really interesting, I think.
Well, not really the question, but for desperate people who wants to use all this stuff in Java 7, they should consider look at the Google Guava. A lot of stuff is here, optional, collections API, etc. Except lambdas, of course.
Right. So yeah, if you want to play with some of these ideas, look at Guava, because there's some cool stuff like optional and things in there, and a lot of collection stuff. Yeah, and if you do want to start playing around with lambdas, you can start refactoring your code towards lambdas without having lambdas. I mean, I don't know if you noticed, but when I extracted the functional parameter, IntelliJ automatically created those as anonymous inner classes. So you can still use anonymous inner classes as a path towards refactoring towards Java 8, even if you're not using Java 8 just yet. Any more questions? Yes?
Okay, and for me, Java 8 is a new technology. What about performance?
So,
What has been your experience on real life, large enterprise?
So my experience, so not my personal experience, but having spoken to lots of people who work on financial exchanges or large organizations or whatever, they are finding the performance much better. The Oracle guys, they are the Oracle guys, but the Oracle guys say that for the majority of applications, when they move to Java 8, without doing anything to their tuning of their garbage collector, they will get better performance. I suspect if you have a highly tuned garbage collection in your Java 6 or Java 7 application, I'm not sure you're automatically going to get faster in Java 8, but the potential is there. They've done a lot of work around that area. I know that LMAX, where I used to work, got much better performance from moving to Java 8. Eventually it took a bit of work and a bit of tuning, but they did get better performance from Java 8. So it's, from a performance point of view, it's definitely seriously worth considering, even if you've never used lambdas and streams. Yeah.
I've done some small testing, and I find that the performance for Java 8 constructs in terms of looping is somewhat significantly slower than a bare for loop.
Right.
Depends on what you're bare for looping on. Like I've done it across 1 million integers, and 1 integer's for loop is going to, that's your baseline. If you were to throw that on a fork join framework, 32 buckets, that's overhead, and it's going to be slower. If you parallelize it, it's going to be faster, but still not going to be as fast as racing through, chunks of contiguous graph and stuff. But there are significant work that you're doing in the loop, then you're going to get some kind of advantage that you parallelize.
Right. So
It depends. Mileage.
for those in the back, the short version of that is there are differences in performance in looping over via Java 8 or via a for loop. So do performance tests if this matters to you, because you don't know. I mean, the thing is, the Java 8 stuff is designed to be parallelized. So if you can go parallel, and if you have enough data, and it's interesting enough, and complicated enough to go parallel, you might get gains. But for something like looping over 10 things, then you certainly shouldn't go parallel for that stuff, because that's never going to get a gain. Yes?
But to that effect, we were saying it's only 10 things.
Right.
There's not much difference. The code readability is worth it, even though it might be slower.
But, I mean,
some people, there's just you're
for that point of view, I would say if you don't have hard performance requirements, code readability should always come first, not performance just because performance. If it doesn't matter, readability should always come first. So yeah, always consider that. One last one?
One last one.
One last one.
Because during the parallelization, you also have to take care that you don't go and do, say, I/O on that parallel stream as well. Because you're not providing a thread flow or anything.
Sorry, say that again?
So when you do the parallelization using the parallel API
Using parallel streams, yeah.
Yeah, you should not be going on the I/O, right? On each thread, because then it's blocking the whole thing.
I think the answer would be it depends. But yeah, going parallel using streams to me sounds deeply dangerous unless you know what you're doing and you tested it. Because I think a lot of people are going to use parallel as a magic incantation to be like, oh, faster, right? And it's not, because if you go parallel, you have to bring it all back in again at some point. And you also have to understand, are we running on different machines perhaps, or are we running on, well, that's probably not going to happen, but have the CPU architecture and cache sharing and all that stuff. So parallel is not a magic incantation, and you should be careful. You should be thinking, am I doing I/O? Am I doing stuff that's just computation on the CPU? What are the implications of this? Okay, thank you very much.
Thank you.